Welcome to this next video, part of iOS reverse engineering regarding modifying the app. If you're watching this from YouTube or if you didn't follow the previous workbook or video, please also take a look because this is a follow-up step. In the previous video, we already analyzed an app and figured out there is an isJailbroken function which returns a boolean. And in this video, I will show you one way to patch an app so we can bypass this jailbreak detection. In Ghidra, you can edit the assembly code, and another way to do this is to directly modify the binary via a hex editor. So to continue with this damn vulnerable Android application, we found out there is a function isJailbroken which returns a boolean or a byte if we look into the decompiled Objective-C code. And our goal is to make this function always return false. So the first step is to load the app binary in Frida. If you didn't do this yet, please follow the previous video. And then we will search for a specific function called isJailbroken. Then we get the details of this function. And in the middle, you will see the assembly code, which you can also find some other interesting information. So first it starts with the memory address. Then we have the assembly instructions like sub, add, move, loader, etc. And the registers like x29, x8, etc. But we will not cover assembly in this course. So I will only show you a few basic things which we need here. And what is also interesting is if you go over this code, then you already might get an idea of the checks which are happening here. So for example, cydia.app is an app which is used on jailbroken devices. And if you go over the assembly code, then you also on the right side, you get some more information. So for example, this Cydia app is also something which is used on jailbroken devices. So if we scroll a little bit, then you can already get an idea what kind of checks are performed. So probably it's checking for specific binaries and applications. If they are installed on the device, then it will detect it as jailbroken. But the most interesting thing regarding the patching is this jailbreak detection isJailbroken function. So this function has some input parameters and it returns a byte. So in this assembled code, you can see local 11 is the byte value. And there are a lot of if statements. And at the end, in these if or else statements, the local 11 byte value is getting a value 1 if this function detects that the device is jailbroken. So the most simple fix I can think of is if we change this local 11 value to 0, or just let this function always return a value of 0. So you might notice if I click on return, in the middle in the assembly code, you can see the address or the line where this return is happening. So if I click on local 11, then this is the assembly code which is applicable to set this value. I will not explain this in detail, but if you go to the documentation of ARM, then the AND operation is a bitwise AND, performs a bitwise AND of a register value and optionally shifts the register value and writes the result to the destination register. So in this case, the meaning of this line of code is that it writes the value of param1, which is the return value of the isJailbroken function, into a register called W8, and the default value is 1, so OX1. Now I'm going to patch this instruction because I think this is the line we need to change. So you can do right mouse click, then patch instruction. And I'm going to change this bitwise operator to a move, so that directly set a register value. And then it already prefixes with W0, and W0 is the register for the return value. And in this case, it's pretty easy. In this W0, I want always to put the value 0. So this will be my fix. So if you press enter, then already this assembled code is changing to return 0. This is exactly what I want. So isJailbroken should always return 0, which is false. And this is all we wanted. So now I can go to File, Export Program, and then you have to choose Original File, and then the location. This is an information message, which means the export was successful. So apparently I saved it in my home directory. So we can copy this binary and then we can just replace the binary from the original application. So this was the extracted damn vulnerable iOS application IPA file. We have the payload folder, we have the app folder. Within this app folder there is the binary. So yes, I'm now going to replace this binary. Replace, that's all. And if you remember from the previous instructions, if we want to repackage the IPA, then we just have to zip this payload folder. So zip -r from recursive, and then the name of the app, so v2 patched.ipa for example, then the directory payload with a / at the end. Now we have this patched IPA file, and now I want to prove to you that it worked. So I have this Mobile Hacking Lab device to be able to easily install apps. So of course you can also use your own iOS device and install it via a libiMobile device or some other tool if it's jailbroken. But in this case, first I have this original damp vulnerable iOS application. If I launch it and if I go to jailbreak detection, jailbreak test number 2, then it says device is jailbroken. Now I'm going to uninstall this app and I want to install this patched version we just exported via Ghidra. So let's install it. Then we start the patched application. Then we go to the same option. And then go to the same option, jailbreak detection 2. Device is not jailbroken. So this proves our patch is working. And then to summarize what we did to patch this application, we changed the is jailbroken function to always return false, and we did this in assembly code. So if you don't have any knowledge of assembly, this might be something generic that you can try. But what I basically did, I just looked into the function in Ghidra, the disassembled code, without having too much knowledge of assembly. And then I just looked up how can I change the return value to 0 of a function. And it turned out to be this move w0 with the value 0. So this was one example about patching an application. So I hope you enjoyed it and see you in the next video.